Well, I work with free radical damage and how the free radicals affect every aspect of organismal life, how they affect mating, longevity, and overall health span. My talk at the conference this year is about how we can use hormesis to actually lower free radical damage and therefore improve organismal performance. I work with insects, and the way that I normally induce free radical damage is by using irradiation. So ionizing radiation would readily split gaseous oxygen and water and create free radicals. This process eventually leads to flies, in my case, that don't fly as well. The females decide not to mate with them because they can tell there's something wrong, and they live shorter. So I use low oxygen approaches, either very low oxygen hypoxia or no oxygen anoxia, sort of as a preconditioning treatment, so as a hormetic treatment prior to irradiation. The thing that this does is that creates a boost in antioxidants. By being put in low oxygen, cells automatically prepare themselves for the reperfusion of oxygen. And one of the things involved in this is the making of protective chemicals, such as increasing the activity of antioxidants, heat shock proteins, in the case of invertebrates, the sugar trehalose. When you then irradiate these insects that have been in anoxia for about an hour, then they suffer much lower levels of post-irradiation free radical damage. So they have their less oxidative damage to their tissues, to their lipids, their proteins, their DNA. And almost immediately this manifests itself by higher treatment survival. After that, you get higher flight ability. The females, now they can't tell. Now the irradiation damage that we were inducing before, it's not there, so the females can't tell these males were irradiated. And so they freely mate with them. Interestingly enough, this changes the rate of aging. So as you look at sort of survivorship curves over time, the rate is improved, so these males not only live longer, but the rate at which they're dying early on in life is lower. And so females can tell, so then we take aging flies that were treated with anoxia, and the females prefer to mate with them than with flies that were just irradiated. But the female cannot tell whether this aging fly with the hormesis treatment is just as good to them as a fly that didn't get irradiated at all. So the improvement, both by lowering the damage of irradiation, it's so big that these males tend to live sometimes months longer than their counterparts, while remaining very active and remaining sexually active as well. Part of this, my work now is sort of moving to the idea of the transgenerational effects. So we're looking at how, my lab is at New Mexico State is looking at how these males that receive, or these females that receive this treatment at the young age, not only do they age differently, so they have a better rate of aging, but then their offspring and their grand offspring have positive effects of hormesis. So we've been looking at this in a moth model, moved from flies to moths, but still staying with insects. And we see that the grandbabies of these males show a big improvement in survivorship, just by the only manipulation being their grandparent was treated with this anoxic hormesis conditioning prior to irradiation. So we're also looking into how different bouts of anoxia may actually help, so not just a single bout in combination to reducing damage from irradiation, but just by itself, and how receiving multiple of these bouts at a young age may improve your performance, for example, your sexual performance, or how many of your eggs hatch later in life.